Hey, everybody. Well, I'm going to be blunt with you. This activity that you've just completed and that you're going through the answer key is going to set you up for our last test. So please, 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 please make sure you ask questions if you don't understand anything. Make sure you ask for help. Make sure you ask for clarification. Listen to everything I say, because the last thing you want to do is go into this last test and not score well just because you rushed through stuff and you didn't do your own work. You let your partner do the work and you just copied things down. So with that being said, we're going to go through each of the questions. And the reason I'm doing this is because you're all going to be getting done at different times, and you might be doing it on different days because of field trips and whatnot. So the first question is letter A right here. A newspaper conducted a survey to find out how many high school students play video games. The two-way table below displays the data from the survey, and that table's actually off to the side here. So what you have to do is, based on this data right here, so based on the data in the table, which statement is true? So if I look at this and it says 2,451 boys surveyed, and about 29% of them play video games. So if I look up here and it says 2,000, actually right here, 2,451, that part of it's true, and it says about 29% play video games. If I look at that, I can see do play video games is much higher than do not play video games. So when it says about 29% of them play video games, what I would need to do is I would need to use my calculator and see what the percent is. But when I look at 1,500 and this is only 2,400, well over 50% play video games. So there's really no math involved. Okay, a little math. You have to have common sense to say, no, this is way over 50%. So that's not true. B, there was 2,996 girls surveyed. That's true. And about 45% of them play video games. So 45% of them play video games. Again, if I look at this, you might say, well, that's pretty close. Then all you have to do is take a calculator and take 1,361 and divide it by 2,996, and you should get about 45%. Now, let's look at the other ones. Let's say you don't have a calculator. There is 5,470 students surveyed. That's true. And about 54% of them do not play video games. So when I look at that, see how this number right here is less? So that tells me right away that this is false. It's less than 50%. No calculator needed. And then there are 2,493 students surveyed, and about 34% of them are girls. That's true, who do not play video games. Well, if we look at that, it's not going to be 34%. So a lot of these are true, like the first part is true, but then you really have to delve into the second part of it. Then you have to start to figure out what's true. And you could use a calculator, but a lot of these are just obviously wrong. So the correct answer is B. Explain how you came to this conclusion. You might have something like, the 2,996 girls surveyed is true. And when I took 1,361 and I divided it by 2,996, I got 0.45. And when I convert that to a percent, it's 45%. So let's look at the next one. A principal surveyed 75 seventh graders and eighth graders students. So there's 75 total. She asked them if they prefer to obtain news from the internet or to obtain news from television. She created a table to display the data. Based on the table, select the 3 correct statements. So letter A says 49 eighth grade students participated in the survey. So if I sit here and I look at it, Here's the 8th graders. 10 plus 15 is not 49. Cross it off. A's wrong. Let's look at C. 26 out of 49 students prefer to obtain news from the internet. Well, when I look at this right here, it's 26 total. That's true. But are there 26 out of 49 students? That's where all of a sudden you start to be, no, that's false. No, it's false. So the correct answers are B, D, and E. Now the thing that might throw you for a loop, 3 out of 5 is 60%. It's also 6 out of 10. It's also 9 out of 15. So when you look at 8 out of 25, it's also 16 out of 50. So you got to keep those things in mind as you look at this, because you might say, well, it's 1634. Well, that's this. If you add those two numbers together, it's 50, and you can take 8, double it to get 16, take this, double it to get 50, so it is 16 out of 50. So that's this right here. And 3 out of 5, that's the same as this for the most part, when you look at percentages anyway. Well, it's actually the same as this over here. You can reduce it to 3 out of 5. So again, take a look, make sure you get the correct answers, ask questions if you have any. So let's back up here 1 second. The 3 out of 5 is when you looked at there's 25 total. I think I explained it wrong. So if there's 25 total, and so 3 out of 5 would be the same as 15 out of 25. So when we look at C, I tried to highlight things to help you out here. A school club has a t-shirt sale to raise money. After the sale, an inventory showed 108 blue t-shirts and 96 green t-shirts had been sold. So what do you do for that? Well, look at green and add them up. When you add these up, do you get 96? When you add this up, do you get 108? Because you should. B did. And then the size of the t-shirts includes 60 small. So when I add this together, it equals 60. When I add this together, it's the 86, and I add this together, it's the 58. So if you look at all the combinations, like this added together is 60, and this is 86, but when you go this way, you don't get the correct numbers. So you just have to add up the numbers of everything and see where it works and where it doesn't, and B is the only spot where you can add up the numbers horizontally, and it adds up to 108, 96, and vertically, and it adds up to 60, 86, and 58. When you look at D, D's more of a logic one than anything. Now, first of all, when I look at these dots, and you draw in a line, I drew in a line of best fit, approximate line of best fit. And when I look at it, one, you know it's going to be positive. So right away, you got to look, okay, which ones are positive? Well, they're all positive. Okay. So what I did was then look, okay, let's look at the y-intercept. If I draw approximately where this would be, it would be approximately 2. So it's probably going to be either this answer or this answer. It's not going to come through 0. It's just not. So I cross this one off. Well, what about plus 5? That's not going to be the y-intercept. It can't be. So now I'm left with either this one or this one. So remember, this is rise over run, 1/2 and 1/3. So what I did was I started at 2. I went up 1 and over 3, up 1 and over 3, and I drew in that line. Then I also tried to draw on the line, it's the dashed one, go up 1 over 2, up 1 over 2. And which line best fits the data? It's this one. So this is how I come up with the answer. So again, you got to know some math. You got to know rise over run. You got to know how to draw lines of best fit. But logic eliminated this one right away and this one right away. It was absolute logic. Then I just had to look at these two to see which one best fit the data. Look at E. There's a lot of coloring here. And this might be the most challenging problem that you have to solve because it's kind of like a puzzle. So Julie wants to know if there's an association between gender and the type of movie a person prefers. She surveyed 500 people. So look at that, it's orange. So I can fill in this table right here. So it says complete the two-way frequency table to display the data. So if this was 280, it just told me that 500 people is here, so I just take 500 minus 280 to get 220. So that's how I come up with that number. So look at this, 35% of the people surveyed prefer comedy movies. So 35% of 500 is 175. So I need this data, and from here, I just take that number and I times it by 35% to get this. Now this blue one right here, 3 out of 10, which is 30% of people surveyed prefer action movies. So I find action movies, take 500, and I find 30% of it, and it's 150. Then I need one more, this green one. 95 people surveyed prefer romance movies. I put that there. Now, once I get these three numbers, I just take 500 minus 150 minus 175 minus 95 to get 80. So there I put infer, because it doesn't tell me up here what 80 is, but I can infer that it's the only number left. I just take 500 minus these, and it's this. So how do I get the rest of the numbers? Well, see how this one's dashed orange? That's this number right here. It says of the females served, 2/7 prefer romance movies. So I just took 280 because it says of the females, I divided it by 7 to give me 1/7, and I'm looking for 2/7, so I just multiply it by 2 and I get 80. Once I know what 80 is, then I can find 15 because it's 95 minus 80 equals 15. Then this one here, 35% of the males surveyed. So it's the male, so I take 220 and I find 35% of it, and it's 77. Once I have this number, 175 minus 77 equals 98. So that's why these are yellow, because I'm inferring. Now you might be thinking, okay, if I know this number, and now I know this number, and we're already given this number, so I just take 280 minus 52 minus 98 minus 80 to get 50. And once I know this number, I can infer this one by taking 150 minus 50 equals 100. And then once I know that number, I can figure out this number. So again, it sounds like a lot, but just take it one step at a time and use your common sense. Seriously. This is all about common sense. This is the type of stuff that, as an adult, you may have to figure out, and you may have to use more of your math sense to figure stuff out. Is it a good buy? Is it not a good buy? Does it make sense? Than the actual math where you have to plug it into a calculator. All right, so F. This scatter plot shows water flowing from a hose. It gives a line here's the line of best fit for the scatter plot can be described as y equals 4/5 x. And it's right here. It's already on there. And you can see how they get 4/5 right here by this growth triangle. Now it says, use the graph to estimate the amount of water that would flow from a hose at 45 minutes. Then use the equation to verify. So if I look at here, and 25 is 24, and I showing my work over here, basically every time you go up 2 and you go over 5, or you go, well, it's up 2 lines, but it's actually 4 because each one of these is 2. So you go up 2 slots, which is 4 gallons, and then you go 5 minutes. So that's how they get to 4/5. It's 4 gallons every 5 minutes. So if I would do that in 24, if I add 4 to it and go over 1, it's going to be 28 at 35 minutes. Then if I go up again 4, it'll be 32 gallons at 40 minutes. I go up a 4 again, and I could draw on that line. So at approximately 45 minutes, it's going to be 36 gallons. Now, the second part says use the equation to verify. All I do is take the equation, which is already given. I plug in 45 for x, 4 times 45 is 180. Divided by 5 equals 36 gallons. So my estimate would be correct. G, you look at this data here. A set of data is represented on the scatter plot. Which equation best represents the relationship? Now, I drew in this line of best fit, and I'll tell you why I drew it at 6. Because of this right here. Now, look at the slope. The slope is a negative slope. So once you know it's a negative slope, this positive slope and this positive slope are automatically gone. Automatically. So if I look at here, negative, it is a negative slope, but look at the y-intercept, 3/4. 3/4 is way down here. So obviously, it's got to be this one. It's got to be. None of the other ones even remotely make sense. You got to know a little math. You got to know, hey, this is a negative slope. You have to know that this is the slope and this is the y-intercept. And once you do that, A is the only one that could possibly make any remote sense. H says here you have this table. On the grid, make a scatter plot using the data from the table and draw a line of best fit for the data. So you're going to plot these on the graph. Once you do that, you're going to draw on a line of best fit, and you see how they're always up to. So you always are going to start right here. You're going to split these numbers, and you're going to draw on your line of best fit as it moves up. Now, once you do that, look at your answer. It's going to be approximately 60 to 62,000 for 15 years because I do that right here. Sorry about that. Someone came in and out. That's why you heard the door slam. It's about 60. I'd accept 60. I'd accept 61. I'd accept a little over 62. And I'd probably even accept a little above if you're drawing all this in and you're showing how it happens. Now, the harder part is this right here. It says write an equation that represents the line of best fit if you drew on the scatter plot. So I look at my line of best fit. I'm going to find 2 spots where it seems to cross where the lines crisscross, the vertices right there. And I find one pretty close here and then pretty close here. So we know these go up by 5. So my rise is 5. And this right here, it's kind of weird. It actually, each one is 1.25. So halfway between 5 and 10 is 7.5. So I know this is 2.5, which is my run. Take 5 divided by 2.5 equals 2. So my approximate equation is y equals 2x plus, and if I come down here, it splits this in half. It's about 87 or 28.75. Probably 28. Trying to think about this. If it's 250, yeah, about 28.75. So what will I accept? If you have something really close to 2x, and if you have something similar to this, because obviously if I drew my line, it should be somewhere in between here. It shouldn't be lower and it shouldn't be higher for the y-intercept because you want to split these. So it's somewhere between 25 and 30 I'd want for this. So again, a lot of logic, but yet you do need to know how do you find slope, which is rise over run, and how do you find a y-intercept. I says using the data in the scatter plot. What is a reasonable slope of a model that fits this data? I just drew it in a line of best fit. Is it perfect? No, it's not perfect, but one, you know it's positive. So it's got to either be C or D. Now, when I look at it, slope equals, well, here it says slope is positive, so that's why I know it's C or D. So I just, again, I find 2 spots that are approximately on it. And if I go from here to here, it goes up 10 years. That's my rise. And it goes over 8 to 12 is 4. So if I take 10 divided by 4, it's 2.5. So that's how I come up with 2.5. Then finally, we got J. J's the next one. When you look at this right here, based on this data, you got bus drivers, you got a box plot, and you got teachers, you got a box plot. You just have to figure out which statement is true. So A says the interquartile range of the distance for the bus driver, and interquartile is between your second and your third. So it's in the box. So I can see that it's 10. And for the teachers, I can see it goes from 15 to 30. So it's 15. So the interquartile range distance for the bus driver's 10 is twice the interquartile range of the teachers. No, 10 is not twice 15. It's actually less than. The range, and then when it talks about range is all the way from where the top one is to the bottom. So for the teachers, it's 30. And for the bus drivers, it's 25. So the range of the distance for the teachers is twice the range of the distance for the bus drivers? No, 30 is not twice 25. The interquartile range of the distance for the bus drivers is 5 miles less than that of the teachers. Now look at D. The range of the distance of the teachers is 5 miles less. So one of these has got to be correct. And we already figured it out. The bus drivers is 10, teachers is 15. So the bus drivers is 5 less than the interquartile range of the teachers. So it's got to be C. It's got to be. You are going to have to know mode, median, and mean on the test. Now, when I look at this, each one of these dots represents a person. So there's 10 people. Now, you got to be careful. Every dot on this one represents just one. So there's 1 dot, 1. When I look at this, it's 1, 2, 3, 4, 5, 6. There's 6 people, but each one represents 2. So 6 times 2 is 12. And then each one of these 3 people represents 4. So 3 times 4 is 12. So there's 10 people total. And when I add all these up, 12 plus 1 is 25. So my mean is simply 25 divided by 10. My median is the middle, and it's fairly easy because of all these 2's. It's if I line them up, 1, 2, 2, 2, 2, 2, 2, 2, 2, then 4, 4, 4. 2 is going to be the middle. The mode obviously is 2 because it's the one that happens most often. Technically, 4 could be a mode, but when we look at the overall mode, 2 is the one that's going to happen most often. It's just this only happens 3, so it wouldn't be the mode. Could be the mode with different sets of data because there's 3 of them, but not this one. Age of inauguration. First thing I'm going to do is I have to do the work. I have to put them in order. Once I put them in order, I see that 58 is the middle. That's the median. I add all these up and I divide by 11 because there's 11 numbers, so 649. I did this 2 or 3 times to make sure it was 649 and I didn't plug in a bad number. So there again, if you're working with a partner, both of you do it. Both of you see if you get the same number and figure out and double check, make sure you're correct. So 649 divided by 11 is going to give me my mean. And my mode is 55 because it happens 3 times. And then finally, the last thing you're going to have to do is you are going to have to draw a box and whisker plot on the test. And we've done these. We've done activities with these. So nice thing is these are already in order. So I count up 5 and I count down 5. So right here is the middle. So what do I do to find the middle if it's between 2 numbers? I add them up and I divide by 2. So 42.5. Then I put my line right here. So there's 5 numbers above and 5 numbers below. So what I counted is 1, 2, and then 1, 2. So this is the middle number for the lower quartile. So I draw another line at 39. I look here, there's 2 numbers and there's 2 numbers. So this is the middle. This would be the 3rd quartile. I put a line at 48. I draw my box in. I like labeling these so that way the teacher knows exactly what my numbers are, but I should be able to read them from here. Then this lower number is just right here, 32. I put a dot. My high number is 52. I put a dot there and I draw the whiskers. Now n is a little different and it's a little tricky. So I did the same thing and it's between 5 and 5. So finding the median was fine. Well, it's 5 because it's right in between. So 5 plus 5 is 10 divided by 2 is 5. So here's where it gets a little tricky. Again, same thing. I have 2 numbers above, 2 numbers below. So here's my lower quartile. I draw that line at 3. I go up 2, and then there's 2 right here. So here, 7 is the middle of my upper quartile. So I draw the line at 7, draw my box. But notice how there's 3 3s here. So my low number is 3. So I put a dot there because that's also my bottom whisker. But on the top side, it's 9. So I put a dot at 9 and I draw the whisker on this side. So make sure you're not just copying, make sure you're asking questions. So when you take the test, you do well on the test because you understand everything. Bring your papers up. I can try and re-explain it to you. I can go over things with you. I can help you prepare for the test. So good luck. And again, let me know if you have questions. Bye.